Welcome to Homework Lib.
All right, so there are 4 parts to this problem. We're going to rank these compounds in order of their reactivity to electrophilic substitution. There was a question like this in the chapter. It's a slightly more difficult, right? So we're going to go ahead and start with the 3 in A. So we have chlorobenzene, we have dichlorobenzene, and we have regular benzene, right? So I'm going to do, I'm going to number 1 being the slowest and 3 being the fastest is going to be my key here. There's your legend. So if you look at the 3 options we have here, right? So we're just look at all the substituents. Obviously, benzene is going to be your standard, right? That's when you have H as a functional group or a substituent, right? Versus 1-chloro, which is a slight deactivator of the ring, and you have 2 chlorines, which is going to be twice as deactivating as well. I shouldn't say that, but you're going to have an additional substituent that's going to contribute to the deactivation of the ring. So it's safe to say that dichlorobenzene is going to be slower than regular monochlorobenzene, and then both of those are more deactivated than regular benzene. So benzene in this case is going to be your fastest because you have mono and dichlorobenzene, which are both deactivated. So similar situation with B here, right? So you have in this option, you have para-bromo-nitrobenzene. So you have 2 deactivating groups. In this substrate, you have 1 deactivating group compared to phenol, which is an activating group. So it's pretty safe to say that you're going to have phenol being the fastest in this case. So which is more deactivating, having a nitro group by itself or having a nitro group and a bromine? So bromine is going to add more deactivation to the ring than having so like nitro plus bromine on the same ring is going to be a more deactivated ring than just nitrobenzene, because the bromine is going to deactivate that ring a little more. So nitrobenzene is going to be faster than para-bromo-nitrobenzene for sure. Oh, that's a 3. I meant to be a 1. Sorry, that's the slowest. On to the next problems. Right, so you have fluorobenzene, benzaldehyde, and orthoxylene. So xylene is dimethyl benzene, right? So they're ortho to each other. Doesn't matter. The methyl groups are both activating. You have this aromatic group here that is aromatic. Oh man, they're all aromatic. You have this ketone group. No, it's not a ketone. It's an aldehyde. I promise. I have a degree in chemistry. It's an aldehyde. Regardless, there's a carbonyl, which means that it's going to be deactivating. And you have fluorobenzene, which is also deactivating. So it's safe to say that the only one with activating groups is going to be the fastest towards electrophilic substitution. And then which is more deactivating, having a fluorine or having a carbonyl group? And the answer is fluorobenzene's only slightly deactivated, while benzaldehyde is fairly deactivated. Those carbonyls are withdrawing a lot of electron density. So and in this last problem, D might seem like it's pretty difficult, but if you notice, they all have cyano groups. So essentially, you can forget about the cyano group and just look at the other groups that are on the ring, and are they going to activate it, or are they going to further deactivate the ring? Because those cyano groups are pretty largely deactivating, right? So regular. So you have cyanobenzene, you have paramethyl cyanobenzene, and then you have para-methoxy-cyanobenzene. So if you think about these 3 substituents, you could put an H here. So they're all para. One has a hydrogen, one has a methyl group, and one has a methoxy. So you could even just go ahead and rank those in order of activation, because they're all activating. Well, I should say H is activating. H is like our reference. But H is less activating than methyl and methoxy, right? So regular cyanobenzene is going to be the slowest here. So I'm going to give it a 1. And then which is more activating, methoxy or methyl? And the answer is methoxy, right? So the methoxy is going to activate the ring. Maybe it accounts for the deactivation from the cyano group, right? But so it's gonna add electron density to that ring, but it's not gonna add as much. It's gonna add more electron density than the methyl group will. So therefore, they're all being deactivated by the cyano group equally, but then whatever that para substituent is, or the other substituent on the ring, is going to counteract that deactivation, being that they're both activating substituents, right? So cyanobenzene is going to be the slowest. Methyl is slightly more activated than the cyanobenzene, and then methoxy is more activated than both the methyl cyanobenzene and then regular cyanobenzene.